皆さん、こんにちは。僕は柳エドソンさんです。僕はブラジル人です。僕のじいちゃんとばあちゃんは日本人です。すみません、今英語を話す。ありがとうございます。And I promise to the translators that I'll be speaking very slowly. And I know I tend to speak fast, so please forgive me in advance. Currently, I'm a director of developer experience at Red Hat. Just in case you want to follow me, my Twitter handle is @Yanaga. And I talk a lot about DevOps, microservices, Java, Java EE, and software craftsmanship, and best practices like the ones I'm going to present today. I'm also a Java champion and a Microsoft MVP. And I work for Red Hat, which I believe is a very cool combination. I hope you can agree with me. And just to give you a tip, I just recently released this book from O'Reilly, Migrating to Microservice Databases. If you go to this URL or to my Twitter profile, the pinned tweet has a link to the book. And I brought 4 hard copies today, which I would love to share with you in the end of the session. So if you want to have a copy, you can grab with me later. So I have 4 copies. So I don't know how I'm going to share, but the first four can pick with me. Okay. And I always like to start my talks with this quote from Forbes. Now, every company is a software company. You don't work for a bank, you work for a software company. You don't work for an industry, you work for a software company. Because software is changing the world that we live. Some people call this digital transformation. I like to think about that as a digital economy. Because when we're talking about economy, we're thinking about how people interact with each other. And when we're talking about digital economy, we're saying that software is changing the way that people interact with each other. And some great examples of this transformation are that the largest car transportation company in the world owns no cars, which is Uber. The largest lodging company in the world owns no real estate, which is Airbnb. The largest online retailer in the world owns no stock, which is Alibaba. And the largest content provider in the world produces no content, which is Facebook. All of these companies, they have something in common, is that they only exist because of software, and the software that they are producing is changing the way that we interact with other people. And it's very nice to see that in Japan, again, technology changes the way that we interact with other people. That's why I believe that we, as software developers, we are some of the most important people on Earth right now, because we are going to improve people's lives for the better in the next 1,000 years. And we know that we can improve people's lives, or we can also make them miserable, because we know the experience of using software that is not up to our expectations. So some years ago, I made a choice, and I hope that you can all make a choice too, that I wanted not to just code, I wanted to know that the code that I was producing was changing people's lives for the better. That's why I'm so happy to be here. Again, I'm a Brazilian Japanese. I'm so happy to be able to share some knowledge, some tips with you today here in the land of my grandparents. And I hope that some of the tips that I'll be able to share with you today will be useful to you. I also believe that software is a craft, is not an industry, is not engineering. And I like this quote. I saw this quote from the Museum of Computer Science in Palo Alto, California, saying that computer programming is an art because it applies accumulated knowledge to the world, because it requires skill and ingenuity, and especially because it produces objects of beauty. I believe that as software developers, one of the greatest pleasures that we have in our lives is to see that we created a very beautiful code and that this code is helping peoples in production. So that's the invite I want to ask you. And last thing, this quote is from Julian Apello from Management 3.0. No matter what other methods you apply to achieve competence in a social system, and software is a social system, in the end, it all depends on whether people actually care. So I'm not asking you to be perfect. All I'm asking is that you should care about the software that you're producing. Okay? And I hope that you, by being an example, by doing better, you'll be able to share the knowledge that you're acquiring today and with the other days with other people too. So this book, Domain-Driven Design, in my opinion, is one of the most important books that we have recently in the software development field. It was written more than 10 years ago, but unfortunately, not everybody yet knows about domain-driven design. And I believe that some of the problems is that domain-driven design is not that easy to understand. But I'll try to get some of the concepts from the book and explain to you in a very brief way because I have less than an hour to be explaining. And I'm also going to tackle some code smells that you can see in your code every day. So I hope that you will be, something will ring a bell, you'll see some familiar. And I'll show you how you can change this code from something that smells from something that can become beautiful. So first code smell is primitive obsession, is that we developers, we are used when we are creating our classes, we only use primitive values like string, int, integer, long, big decimal, and anything else, which is a symptom that your code is not doing that well. So we should be creating our own custom classes for when we're trying to solve our domain model problems. And if you're thinking about, well, why should I create a new class for when I want to model something of the real world? And Martin Fowler wrote this article more than 10 years ago too. And it's a very nice read. It's publicly available now by the ACM. But the important thing of this article, when to make a type, is that he said that if you're in doubt, if you should be creating a new class or not, then you probably should be creating. Because it's much easier for you to remove a custom class that you created rather than later trying to incorporate a custom class in your system. If you don't create a custom class, probably your business logic will be scattered around multiple different classes in your code. Like for example, if you want to validate the social security number of a person, it's very common for people to just copy-paste code in multiple places to perform server validation, or if you want to print this number in a beautiful way, in a certain formatted way instead of just numbers. It's very common for you to have this logic scattered too. And when you need to change this logic, it becomes very difficult for you to maintain your code. Another very common problem is the null pointer exception because it's the most common exception in the Java world. I'm pretty sure that you hit this exception many times per day. And I think that since I have to speak a bit slower, we won't have time to cover this. But I have many videos on YouTube where I talk how can you handle this problem, so I hope you can check them later. You just have to Google my name, Yanaga. It will be a lot of videos around. But I think that I've talked enough, and I think that the best way for us to learn how to code better is to see code. So I'm going to do some live coding right now. Okay. I already have this project running. I have this project on GitHub, so you can check it later too. But if you want to check my GitHub profile is Yanaga2. So I try to have the same handle everywhere. So, but I'm going to create first, I'm going to create an order. Okay. Is it big enough? Yes. So, and of course, I'm using Java EE technology, so I'm going to use to model this class as a JPA entity. And if you read some books, some author says that you should not be using technology-specific annotations or classes in your domain model. But I've tried both approaches in some projects in the past, and I've been doing this in the past 20 years. And for me, I think that trying to insulate your model from your technology is not that useful. It's too much work, and you don't get that many benefits. So I'm going to give you an advice today. The advice I'm going to share with you is from Eric Evans from the Domain-Driven Design book, is that if you chose to use a technology, if you chose a framework, don't fight the framework, don't fight the technology. So if the problem of you trying to avoid the problems of technology is too high, then you should just embrace that. And that's the reason why I'm just going to use the JPA annotations directly on my domain model, okay? So you might be wondering why I'm saying that. But if you read some books about domain-driven design, you learn that some authors are against it. I'm not, okay? But that's my particular opinion. It needs to implement serializable interface. As an entity, it needs to have an ID. So I'll add this annotation. I'll add this other annotation. An order might need a number, so I'm going to say integer number. Okay, and I'll stop with that, okay? So another good practice is that we usually, when we're modeling our code, we tend to make our code too mutable, which means that we create our code, and the first thing that most developers do is that they create this class, they ask to generate the getters and setters, and that's it. That's a very bad practice because your code is very mutable. And the tip that I want to share to you is that usually the problems related to specifics on the algorithm or the business logic when you hit these bugs into production, they are not that hard to fix, the ones that are related to behavior, because the hardest problems to solve when you hit a bug in production are the problems related to state. Usually, you have a class, you have an instance of your class, an object in your memory, which has an inconsistent state, which means that, like number, it was never supposed to be lesser than 0. But then suddenly, you face a -1 in your code, and you have absolutely no idea how could your code reach that state. And why does this happen? Because your code is too mutable. Your code is not protected. Because anybody can call this method setNumber and change the value of the number. Okay? So what I'm going to propose to you is that we need to minimize the mutability. We need to increase the encapsulation of our code, which in my opinion, again, is the most important benefit of object-oriented languages, encapsulation. So how can we change that? So I'm going to remove these getters and setters. Some frameworks, like for example JSF, requires you to have getters and setters for you to be able to get the data from the interface and put in your business domain model. This example project that I have here, it can show you some ways of achieving that with immutability, but I think I won't have time to show you that today. But again, I have videos and a code on GitHub that will show you how to do that. So what I'm going to do, order. No number in my system can be negative. How can I protect that? Well, I think that integer is not a good class for that. I need to create a custom class. So I'm going to create an order number. All right, so let's create this order number. All right. And let me get back to order. Talking about domain-driven design concepts, the two most important tactical concepts of domain-driven design that I'll show you is that you have entities and you have value objects. What's the difference between them? Entities, they have many different properties like a person. A person can have a birth date, can have a name, can have an address, can have a telephone. All of these properties can change over time, but the person is always the same, right? That person has an identity. Like me, I changed my address, I changed my phone number, maybe I even changed my sex, but I'm still the same person. I have an identity. When you find a class that has this behavior, you call that an entity. In domain-driven design terminology, that's an entity. And you have other types of classes. For example, phone number. If you have a phone number which is 11-11, and you have another object of the same class with the same number, 11-11, does it matter for you if I change the objects in your system? Does it change the meaning? For most systems, it doesn't. Like you can switch the phone number for another object phone number with the same value, and the behavior of this system is the same, right? So these types of classes that you create, where they are only meaningful regarding their value, these classes are called value objects. And all value objects should always be immutable. Once you create one, you never change that. And immutability has some benefits, which are you can never have an inconsistent object, a value object, because when you create an object, you're always creating it right. Nobody can change the state of immutable objects. Value objects are always thread safe, which means you don't need to synchronize your code, you don't need semaphores or something like that. And you can encapsulate the behavior. So I'm going to show how can I achieve that. So go order number, it might represent a digit, so let's say it should be implemented serializable because of Java, JPA. It also, internally, I might represent integer order number like this. But since it is mutable, I'm going to make it final. And if it's final, I need to initialize that with a constructor, okay? And if you ever read Effective Java book, you know that constructors are not a good thing. So instead of constructors, not that it's bad, but you have better things, better approaches. So instead of using a constructor, I'm going to use a factoring method. So luckily, most IDEs today already have this refactoring, so I'm going to refactor. And going down, replace constructor with factory methods. I'll call it of. And one of the advantages of using a factory method is that I can first, I'm going to check if the value is not null. I can use like check not null value. I'm using a library called Google Guava, so which has very nice static static methods to provide some checkings of the values I receive. And I also want to say that there should be no order number which is below 1,000. So I'm going to say check argument value needs to be greater than 1,000. So when I'm checking the value of the order number here, when I'm constructing the object, I have two benefits. I can never have a wrong order number because it's being checked when I'm constructing that. Okay. And the added value of that is that instead of creating a wrong order number and having an error when you use the object, you are using the fail first or fail safe approach, fail first. Because you have an error when you're creating the objects, which is much easier to identify where the problem is. Factory methods too, you're not required to create a new object, because if you want to implement the fly-width pattern, you could always return the same object. If you look at the implementation of the big decimal class in the JDK, it uses the flyweight design pattern, but I won't have time to code that today with you. And the last advantage of using our factory methods is that you are not required to return an order number. When you use if you use a constructor, you are always required to return that same type. If you use a factory method, you can choose which type to return as long as it is a child of order number. Suppose that later in my system, somebody requires to add a special order number to the system, right? And special order numbers always are above 1 million. So I could just create here, if value greater than 1 million, return new special order number, right? Which is a class that doesn't exist because I didn't create. But if not, I return an order number. And it will work. It can have different behavior as long as special order number extends order number. And maybe later, if you decide that, well, I have too many children of order number, maybe that should be something to think later. You could transform order number to an interface. Okay? So these are some of the flexibilities that you have when you're using a factory method. But I'm not going to do that today. Just keep it this way. Okay? Every value object must implement some methods from the basic JDK. It must implement equals. It must implement hash codes. It must implement toString. How do you implement that? I'm going to do very quickly with you. One of our very simple implementation, if that's an instance of order number, I can perform a cast, return object.equals. And since Java 7, we have these methods from Java, Java objects. We can this.value, other.value, or else return false. If you want to perform an optimization, you can also object. Okay. This is a very nice implementation of equals. There are many other comments about that, but if you want to truly know how to implement a good equals method and know why I'm implementing it this way, I recommend you to read the book called Effective Java by Joshua Bloch. It's a very nice good. That's the book where I took this implementation. Every time you implement equals, you should be implementing hash code, and equals and hash code should always use the same properties on the code. So here I'm going to return objects hash this.value. Okay. This is an implementation which is not that fast, but it's a correct implementation. If you need performance, again, you should read the book and know how to implement a very fast hash code. And with the toString methods, some people use the toString methods to show business strings to the user. That's not the right approach. toString should only be used to present debug information for developers. If you're having a bug into production, you want to use the toString method to print the information, the state of the object, so you as a developer can understand what's happening in the system. And a good implementation is like this one. Okay, so this is again, more objects is a class from Guava, and this is a very nice implementation of this class. If you want to know how does it work, I'm going to create a main method and say order number of 1, 2, 3. Okay, and if I run it, you see, it's saying it's an order number and the value equal to 1 through 3. Okay? And if I try to create an invalid one, must be greater than 0. If I say, let's say that I need to be greater than 1,000. Okay, off 1 to 3. If I run it again, I'll have an error. It will say that that's an illegal argument exception, which is the right exception to be thrown in this case. Okay. What else? Then the next question is, if I want to show business information to the user, how should I do that? Most people don't know this interface, but there is an interface in the JDK called Formatable, which was created exactly for that. It's Java Util Formatable, and I will need to implement this way. Okay, and suppose that I want to present this information as order number needs to be internationalized, or suppose that I want to print order number is 1, 2, 3, but my order numbers always start with an A and a number. Just a silly example. But just to show that how should I do that, I should be using this format to A dash D plus the value. And how does it work? If I say that here it's a toString, and here I'm going to use see how it works. You see, if you use toString, you have the debug information. If you use formatable, using string.format, you get the business information, right? I could also change here. Oh, now the business value has a dash. I change this information. I run. It's already in the system. So that's the preferred way of implementing business values in your code. And the beauty is that if you look, this is a very complete method. It has like many parameters, flags, width, precision. You have the formatter. You can internationalize it if it's if you want to change the dot and the comma for numbers. If you want to write that in multiple languages, that's the method that you want to use, because these methods is internationalizable. Okay, so that's where you should be using. And if you want to know how to do that, you need to read the Java doc of the interface. Okay, you have a lot of information on this interface. And this is basically a good value object. It has all the benefits of value objects. You see that I have no getters. I don't have getters for the information. It behaves like a class. It can show itself, has debugging, knows how to create. I just need to remove this main because I just did that as an example. Let's go back to order. Now my order has an order number, and all of my orders should have order numbers. So let's create a constructor for that. Oh, then you're saying it should be immutable, right? And I should add final. But you know, if I add final, it's too complicated to be using that if that's a JPN entity. So how can you achieve immutability if your properties are not final? Well, the easy way for you to that is that you can never have a public constructor, right? You always choose factor methods, and you don't allow this property to be changed later through setters. How can I do that? I'm going to create a factor method again. Factor. Of. And I say that check not null. Number. So whenever I create an order, I should never have a null order number. And this factor method will prevent me from doing that. Also, just note that my ID turned my constructor into a private one. Hibernate can handle that, but according to the JPA specification, this constructor should be protected, and you should always create a default protected constructor in this case. Okay, so I have to create like protected order. And why do I do that? Because I'm using JPA, and JPA injects the values through reflection, so it needs a default constructors to be able to instantiate, okay? And populate the object. So this is the way how you do that. And order number is immutable. I'm creating an order and I'm checking if the order number is not null. So it's safe for me to create a method getNumber. Okay? My class is still immutable, right? So these are some of the first tips. Now let's think that order can have many items. So I'm going to create a collection here. I'm going to say that private list order items or array list. Okay, and it's complaining because order item doesn't exist, so let's create this class. It needs to be serializable. And whenever you create order item, the first thing that most developers will do is that, well, it's a one-to-many relationship on the database. And what do? They add an entity, they add an ID, they would put this, and go back to order and say, oh, that's a one-to-many relationship, right? And you should also have, say, order, and they would map with a many-to-one. Okay? You would use mapped by on the other side. That should not be your first approach. Okay? If you think about order item, if I have an order, and if my order item has this product, this amount, this price, and if I create another object, another order item object with the same product, same amount, and same price, does it mean something different to my system? Or they should be interchangeable? Doesn't matter, right? For most of the systems, it doesn't matter. Which means that order item is not an entity. It doesn't have an identity. It can be deleted and replaced by other objects with the same values, and my system behaves the same. So it should not be mapped as an entity. It should be mapped as a value object. So it shouldn't be an entity, shouldn't have an ID, and shouldn't know from which order it is from. But how do I implement this behavior in JPA? Most developers don't know how to do that because they use one-to-many. But luckily, since JPA 2.0, we can map this if we just create and add this annotation elements collection, which means that now my order item is a value object. I'm missing other annotation here too. So now I'm going to do this order item and say that it's an embeddable class. Okay, and embeddable classes now I can create. Suppose that a string product amount price. You should not be doing that because product should be another class, amount should be another class, price should be another class, but I don't have time to code everything, so I hope you trust me. You should not be doing this. You should be doing like order number, okay? So in this one, you can create the getters. And again, you're going to create a constructor. You're going to initialize all of that. You're going to create a protected order item. An empty or default constructor. You are going to generate a factory method. And you're going to, again, check all of the arguments. And you're going to check no amount. And you're going to do that for price. That's an immutable object. that you can use inside your order item. Okay, so well, I don't have a reference order. And how does it perform in the database? So one of the things that you should be aware when modeling domain-driven design entities this way is that whenever you have an element collection, this collection is going to be eagerly fetched. Okay? So you'll never have lazy initialization exception on this collection. On the other hand, if you have too many items in your collection, it will be a performance penalty. Because every time you're querying an order, you're going to fetch all of the items too, even though you don't know if you're going to need them. Okay? So this kind of behavior is only appropriate if you know that your order doesn't have many items. If you have orders in your system and it's common for them to have like 100 items, then it would be a very bad practice to be doing that. But if you're not familiar with domain-driven design, I would tell to you that if an order has like 100 items, then maybe an item should not be a value object the way that we code it, should be an entity. Okay? And one of the reasons for that is that only entities, or even better, only aggregates in domain-driven design terminology can be queried against the database. But that's a discussion for another day. As you see, domain-driven design is a very big subject, and I'm only choosing some very nice tips for you to be able to be curious about it, because I strongly recommend you to be doing that. Okay? So that I know all of the implications of what I'm doing. If you ask me later, I'll be able to answer that. But so I'm just giving you some pros and cons very briefly. But let's suppose that it should be you don't have many items, you have like 5 or 6, and whenever you query an order from your database, you're always manipulating the items, though it shouldn't matter. You're always querying them anyway. So suppose it should be a value object in my business unit case, could be different in yours. And what else can I do? Well, what can I say? The first thing that people would use too is that if order item is okay, value object needs to implement equals, hash code to string. I'm not doing now because I don't have time. Entities, you should always, again, implement equals, hash code to string, and formatable if that's the case, but I'm not doing that because of time again. But many people think that, well, I have an order. I need to show the items on the screen. I need to manipulate that. How do I do that? Well, people would say, you just, well, get items. And then my class is not immutable anymore or has a dangerous mutability. And why is that? Well, the list that I'm returning is immutable. It's not protected in my code. Anybody in the system can go and change this item, right? And suppose that my code here is working properly, but some other programmer is in his code, he's modifying my item because I don't allow repeated products in my list. But the other programmer, he is adding repeated products to my list of items. How do I protect my order from this behavior without having to replicate this code all over my project? You need to make this list immutable. And one of the easiest ways for you to achieve that is that you should be doing these classes from Guava. I'm returning an immutable list. As of Java 9, you have like other ways of creating immutable collections. I'm just suggesting one possible way of doing that. You should choose the one that you prefer. So, my list is immutable, but how do I modify that now? If you prevent immutability, then you should always provide a way for clients of your code to change the list. One possible way for doing that as well, suppose that you want to create public void add item, and you say that. First, you should always check not null item. It can't be null, or else I will have a null pointer exception. And if it's not null, items.add item. Then I'm changing my list. Basic behavior. Now you might be asking, how do I prevent people from adding repeated products? And it really depends. You can check, well, you could see, and then you get here, you can get your items.stream. If you say, oh, I want to filter all of the items, so I have item.get products equals item.get products. Okay, so I'm filtering all of the items that have the same products. I don't want to be find any. If I find any item that has the same product, it means that it's repeated. And if it's repeated, I don't want to if repeated is present, which means is repeated, or if not repeated, then I can add this, right? So that's a possible way. So this way, I'm preventing, you can never add a repeated item with the same product on my list. That's one possible way of implementing that. Maybe your customer required you, whenever I'm trying to add an item with a repeated product, I want you to add the amount of the products, okay? That's another thing that you can implement here, okay? But if you created an immutable list, and the only way for you to add an item in your list is through these methods, you know that if the requirements change, the only place in your system where you need to change your code is here. If you didn't encapsulate your data, you would need to look for in your entire system who might be able to change my list. And I assure you, it's a very easy way to insert bugs in your system. Okay? That's how you protect your code. Okay. This is a possible implementation. And let's move to another topic because I only have 10 minutes. So suppose that I have different type orders in my system. Okay? And the first temptation that we as programmers will have, well, I have order and I have special order. Like orders that reach, that are from special customers are special orders. The first temptation about doing that is I'll create a subclass. I have order and special order. We learned that using hierarchies in object orientation is kind of dangerous, so it should be most of the times the last approach that we should be using. But if you know that, another possibility is that my order, I can promote an order to a special order. Then it shouldn't be a type. Maybe it should be a property. Then I might create a way to differentiate special orders from order. I'm going to add a property, and I'm going to use an enum for that. Type. Okay. And I want to create an enum order type. And I can have different ones, normal and special. Okay. And I go back here to order. And again, I should be creating this here. Just order. And suppose the order type, the specialness of the type is determined here on the factor methods. If I say, well, if number, I forgot to. Okay, another class that you could implement is comparable. I didn't think this before, but I think it's a very nice example. I can implement comparable to make my classes comparable. And I'm going to use igual comparison chain dot start, compare this dot value. Okay, so I'm comparing. So now order numbers can be sorted. And I'm comparing them with this value from the other value. That's one possible implementation. As of Java 9, I have a session on YouTube about that. You have a different way of using this. Okay, so now let's get back to order because I thought it was interesting. If order number of 1 million compared to number, which means that if my order number is lesser than 1 million, I return a new order, which I also create refactor. Just create another one. Order number, and this, if it's lesser than 1 million, it's order type dot normal, else special. Okay, you see, I'm using a factor method. I just been asked to, well, now you have special orders and normal orders. The only place that where I needed to go to the system to change its behavior was the factory method. And how do I change behavior with this enum? I'm going to go to this enum and suppose that the shipping information for this product can be different. Special orders, they have a 10% discount. Okay. So how do I compute the discount? So what I only have 2 minutes, so I'm going to do very quickly here. I'm going to use the old way, the Java 7 way, and I hope that you can see my video how to do the Java 8 way. Suppose that you want to have different discount. Discount here is 0, so new big decimal. So I'm going to add a property, discount. And with nums, I can create a constructor. And whenever I do that, I'm going to say, well, discount, it's going to be new big decimal 0.0. And if it's special, the value should be 10%. Okay. Normal, special. What is it complaining? Final big decimal. Oh, I'm missing here. Okay, so I could get discount. That's a way of creating, so you can change the order type. You can get this value. If you didn't know that enums can have properties, that's a very nice way of adding. But enums can have behavior. And that's the subject of some of the talks that I have on YouTube. And if you read the latest version of the Effective Java book, you will be able to check that too. And since now that I'm over time, that's what I can share with you today. Last message is that I truly believe that better software can create a better world for us, for our family, for our friends, for the people that we love. And I hope that I might have convinced you that you can do the same. No matter how small the difference you can make a difference. And that's what I wanted to share. This content is also available on developers.redhat.com. I'm available at my Twitter, @Yanaga. And domo arigatou gozaimashita.